I'm approaching this house with a real mixture of trepidation and curiosity. Within its walls, there's something extraordinary happening. But at the same time, it feels like I'm stepping into a horror film. Because this house has been filled with hundreds and hundreds of spiders. I have to admit, like a lot of people, I am a bit scared of spiders, but I'm also genuinely looking forward to finding out more about these fascinating creatures.
Hello, Alice.
Hello.
Come on in.
So this is the spider house?
It certainly is.
Inside this house, entomologist Tim Cockerill, with the help of spider breeders and experts, has been conducting a unique study of what spiders really get up to in our homes. Even though they rid our houses of flies and other disease-carrying pests, we tend to despise and fear them. Now, for the first time, cameras in every room will reveal a hidden world of drama. Oh, you tumbled down. Romance.
He was very gung-ho.
Absolutely. I think he was going to have to do a better job of courtship than that.
Bloodshed.
Oh, my goodness. Gosh, that was quick.
And exquisite beauty. You'll never look at spiders in quite the same way again. You may even welcome them into your home.
I feel quite maternal towards them, Graham.
So you should.
To begin, I'm going to meet one of the most common species found in our houses.
What's in here?
This is our spider lab. This is the central hub, the nerve centre of Spider House.
Fantastic.
This is one of the house spiders, and it's, as the name suggests, it's one of the most common species that lives in your house.
I thought this was going to be a gentle introduction, Tim, and he's quite a big spider to start with. He's facing towards me.
You're ready.
He's coming straight toward. He just knows, doesn't he? He really does know. Tim, what's he doing now? It looks like he's chewing his leg.
No, he's cleaning himself. So they're very, very sensitive pads on the end of the feet. So it's absolutely imperative that they keep them really, really clean.
So this is quite sweet. This reminds me of a cat licking its paws. Yeah. So why are they in our houses?
Yeah, in many, many ways, a house is perfectly designed to hold spiders, especially the ones that are particularly associated with us, like the house spider or like the daddy long-necked spider. You know, they're nice and warm in the winter and full of pests, full of flies and moths and all sorts of things for them to eat.
Ooh. It suddenly got very active indeed. Goodness me, right, yeah. I mean, this is, I think, what I find difficult about spiders, and I'm sure a lot of other people do as well, is that they can look completely still and completely calm, and then they suddenly spring into action.
I think those kind of responses can either go down the phobia route or fear route or fascination and intrigue route.
So I'm hoping that I'm going to replace some of that anxiety about spiders with fascination. And I think even just this introduction to an ordinary house spider has already got me really intrigued.
We'll see how we get on.
To investigate how spiders turn our homes into their homes, we transformed each room of this house into a spider laboratory. To do this, we needed a lot of spiders. So we turned to insect and arachnid breeder Graham Smith for help.
So these are the new ones coming in, the beginnings of the collection.
I love your labels as well. We've got Daddy, Tangle, Orb.
We collected spiders from other houses, nearby woods, gardens and fields, bringing them to the spider house where we gave each spider a temporary new home. We installed special cameras and turned the living room into our control centre, allowing us to record what spiders get up to when we're not looking. One place where you're almost guaranteed to bump into spiders is the bathroom.
Welcome to the bathroom.
Oh, Tim, just as I got used to one of them, there must be about 20 in that bath.
My journey through the house begins with a question. Why do we always find spiders at the bottom of the bath?
Most people are familiar with spiders in the bath.
Yeah.
And it's not just fluke, there is an actual reason why a bath is a place where spiders accumulate. We've been looking into this for the past few weeks and we've filmed some really interesting things. So we've got some clips to show you. Look at this. This is some film that we took earlier on in the week. And this is a spider drinking.
That's amazing. I don't think I'd ever really thought about spiders drinking.
It's a very delicate thing, isn't it? And
So it's just moving its mouth parts together?
Yeah, well, they also have a sucking stomach, so they can create pressure to suck in liquids through the mouth parts.
Right.
So the first reason, why do we find spiders in the bathroom? Spiders need to drink just like the rest of us, and the most humid room in the house, of course, it's going to be the bathroom.
Our houses are incredibly dry environments, thanks to central heating and damp proofing. So for spiders, bathrooms make perfect watering holes. But water's not the only reason we find so many lurking in our baths.
If I was to design a house spider trap, a spider catching trap, well, it would probably end up looking pretty much like a bath.
Right.
So look at these house spiders here. You can see that they can get up the sides kind of slightly, but as soon as they get onto the flat side, none of them are able to climb out of the bath. And let's just watch this one. So she's trying her best to climb up this smooth surface. But she can't quite make it.
Oh, he tumbled down. So they're coming in, they're attracted by the idea that there could be water in there, there's moisture around, but once they've fallen in, they find it very difficult to climb out.
That's right. Now, there's actually a really interesting reason why the house spider can't make it out of the bath. And if we look in really close detail at the ends of the toes, the ends of the tarsi of the house spider, and you can see right at the very tip of the toes are these two big claws.
They're like big curved combs, aren't they?
And these are perfectly well designed for walking on a web by hooking on with these claws at the end of the toes.
Yeah.
Now, because that's the only way of walking around they've got, well, they can't climb up smooth surfaces. They can't get out of the bath.
So when thirsty spiders are lured into the bath, they are trapped and often face an even worse fate. Because many people get rid of them by washing them down the drain. But how does this affect the poor spider?
This way then. To me.
Out in the garden, Tim and Graham are going to find out, using a sink with a specially constructed transparent U-bend.
I know you said we brought everything but the kitchen sink, but this is really taking the biscuit. So, Graham, we are trying to find the answer to the question, what happens when a spider gets flushed down the sink? Because that's what most people do, isn't it? Or lots of people, obviously not us included.
No, bad thing.
Do you want to say when?
That'll do it.
Right. So we'll try this one, shall we?
Yeah,
This is a house spider. So this is dinner escaping there, those flies flying away.
Excess.
So this is a house spider inside its nice tubey web there.
Yeah.
just to coax him out. Oh, that's an adult male.
Adult male, yep. Nice one.
And so first question, what's going to be his response as he hits the water? Sink or swim? And there he goes. Oh, wow, look at that.
It doesn't notice the water.
Most spiders here in the UK can accomplish this minor miracle. By spreading their weight over their 8 legs, they simply don't break the surface tension of the water. On top of that, their bodies are covered in water-repellent hairs. When submerged, these hairs trap a layer of air around the spider, which means it never really gets wet.
So maybe if I go and watch for the response, and then are you all right to man the plug?
You tell me when.
Great. 3, 2, 1, pull the plug. Whoa,
One spider.
there he goes. Oh.
This might look like a terrible ordeal for our house spider, but even when fully submerged, he can still breathe, using the bubble of air trapped in the hairs around his body. Using this spidery scuba gear, some species can survive underwater for several hours.
So it looks as if this spider has survived the experience perfectly well. It whooshed through the U-bend, and in fact, I can't even see a single drop of water on it. Now, this is what's happened in our experiment, but in real life, do you think it'd be the same situation?
No. A spider really being washed down the sink, bad idea.
And that's because the water in our drains is never just water. It contains soaps and detergents that weaken the surface tension. And it doesn't take much to sink our poor spider.
There we go, straight in.
Without surface tension, the spider can't walk on water or trap the air he needs around his body.
Now, I think we should rescue him really, really quickly. So it's perfectly fine for us to flush our spider down this sink with nice clean water, but when people do it at home, it's not just water. It's shampoo, it's shower gel, it's soap, washing up liquid. If you flush a spider down the sink in your house, well, you're probably going to kill it.
You're going to kill it. Yeah, it's not a nice thing to do.
So the kindest thing to do if you find a spider in your bath is to find a suitable container and take it outside. Many spiders cope surprisingly well with water. But there's one that's adapted so well, it's gone one step further.
Some spiders live next to the water. Some spiders live on the water, but this guy lives under the water. This is a diving bell spider. It can swim around as agile as a fish. It eats, sleeps, and even breathes under the surface of the water.
The diving bell spider carries its own air supply trapped in the hairs on its abdomen. It almost never needs to leave the water. When the oxygen in its bubble is exhausted, it simply flicks its abdomen above the surface, capturing a new batch of fresh air.
It can last for hours, even days underwater without coming to the surface. It's so successful that it's found halfway across the world, including in ponds and streams all around Britain. It's a unique spider in the animal kingdom.
We've seen how spiders find water in our homes, but in order to survive, they also need to eat. And they're not interested in our food. Here in the dining room, Tim and Graham have arranged a very special dinner party where only guests with 8 legs are invited. For spiders, supper usually begins with one of the most beautiful and mysterious pieces of engineering in the natural world: the web.
Welcome to the dining room.
This looks suitably spooky, Tim.
That's the idea. So this is the room where we're going to have a really close look at spider webs. So we've let all sorts of different species of spider really explore the place and make webs in different nooks and crannies of the room. On the dining table here, we've got a grand tour of web design in spiders hidden in amongst the cutlery and crockery.
Spider webs come in a huge variety of shapes and sizes, from simple tubes to sheets and tangles.
I see why it's called a tube web. It is, isn't it?
Yeah, so this is built trip lines from the opening of that mouth, so it's very thin threads.
Right out almost the edge of the glass here.
You can find all of these different webs in and around your house. But the familiar orb web is the most complex and advanced. The spiders responsible are the most industrious engineers in the house, the orb weavers. They can find their way in from the garden by hitching a ride on shopping bags, coats, or boots. These spiders are the best builders you'll ever have in. They can weave an entire new home in less than an hour.
So, Tim, you've got a common or garden orb spider, and we're going to see if it's going to actually make a web for us.
That's right.
I do like these spiders. I think she's quite pretty. They've got lovely stripy legs.
And she's a very intricately patterned thing.
We're giving this orb weaver a new home, one of our picture frames, so that our cameras can record her web building in minute detail.
She's certainly spinning silk, quite a lot of silk, drifting in the air here.
These are experts in insect behaviour because they've got to put their web in just the right place to capture flying insects. And so anywhere where they can feel exactly the right kind of draft, just the right kind of air movement, where insects might be likely to be flying, well, that's exactly where they'll put their web. And as she walks around the picture frame there, well, she's doing what she would do in the wild. She'd kind of survey her territory and look for those attachment points to put that first layer of scaffolding down almost.
Come on, little orb spider.
We waited all night, but sadly, the carefully positioned frame didn't take our orb weaver's fancy. But the plants by the window did. And it was here she built her home. By first releasing a lone strand of silk, which catches on a nearby leaf. This is the moment a new web begins. From this main line, the spider drops downwards to form a Y-shaped core structure. Next, she attaches stiff threads like the spokes of a bicycle wheel, over which she weaves a loose, temporary spiral. Finally, the most crucial part. Using this first spiral as a guide, she weaves a tighter spiral of sticky silk. In just under an hour, in mid-air, this tiny spider constructs a natural marvel. A perfect orb web. But no matter what they look like, these remarkable structures are usually built for one thing, and that's catching dinner. To see this in action, Tim's introducing me to the largest spiders here in the dining room.
So are these actually alive?
They are. They look like big plastic spiders, don't they? But no, these are tropical orb-weaving spiders.
They're huge.
Yeah, they're a kind of giant version of the kind of things that we get in our own back gardens. So she's sitting right in the middle of the web, and each one of those legs is attached to a different strand of the web. So what I'd like to do is to see this web in action.
Okay, let's see what happens then.
Okay, I have to hope my aim's good. Oh, and there we are, straight away.
Straight in.
knew exactly where. And remember, the
Yeah.
eyesight's not all that
Yeah.
good on these spiders, so she was using the vibration in the web to really pinpoint where the fly was.
The split second that fly hit the web, she was ready to pounce on it.
Most species of web-weaving spider are virtually blind. Even when prey is nearby, they often won't sense it until it moves. Spider silk is particularly good at transmitting even tiny vibrations. Sensitive hairs on the spider's legs detect the silk's slightest movement. Using each of her 8 legs, like an ear, she pinpoints exactly which part of the web the movement's coming from. And strikes. The web is a finely tuned listening device. A physical extension of the spider's sensory world. But detecting prey is just the first stage of spider supper. Next, they have to battle insects that are nearly as big as them. Over the course of several weeks, our cameras captured many of these life and death struggles.
So we've had cameras in every room filming.
We've seen some incredible behaviour. And these are the things that are going on in your houses and in gardens all the way around the country.
The house spider uses strength and speed to immobilise its prey. It simply charges out and bites its victim. But orb weavers use a different technique. It's called attack wrapping.
This spider hasn't bitten the fly yet, it hasn't injected its venom. So
Oh,
that
really?
first stage is just using that multi-stranded silk. There you go, look at that. You can see how
Yeah.
it's not just one line of silk, it's like a sheet of silk that's
Yeah,
coming straight
yeah,
out from the
yeah.
abdomen.
Oh, he's wrapping the fly up like a mummy.
Because of course it could be anything in the web. It could be something nasty like a wasp with a really nasty sting on the back. So it needs to immobilise it before it feels safe enough to get close to inject that venom.
It's quite extraordinary, that sheet of silk that comes out. It's almost like cling film, isn't it? Wrapping its feet up in cling
Exactly,
film.
yeah.
With the prey immobilised, finally, it's dinner time. And if you're eating dinner yourself, a word of warning. Spiders have truly terrible table manners.
Or is it actually eating the fly?
And so this is the external digestion of the prey. So the spider's stomach and its gut and its esophagus are adapted to accept liquids only. In fact, there are filters inside to filter out any solid food. So all of that food needs to be liquefied before it goes into the body.
Wow, that's amazing.
First, the orb weaver uses special teeth on her jaws to pull the fly apart. Then, she releases her own digestive juices all over it. These enzymes break down and liquefy the insides of the fly, allowing the spider to simply drink her meal by sucking through her mouth. Every year, spiders around the world eat the equivalent weight of the human population of Britain in flies and other insects. By ridding our houses of disease-carrying pests, spiders do us a huge favour, whether we like them or not. But a spider's dinner isn't just handed to her on a plate. A web might look like a passive trap, just waiting for flies to slam into it. But it actually plays a much more active role, harnessing the power of static electricity to reach out for prey. The man who made this remarkable discovery, Professor Fritz Vollrath, is going to show us how this works.
Now we've got this interesting contraption here, and we're expecting that if I attach myself to this, get charged up with static electricity and then approach the spider web, we might see something interesting.
Something very interesting, hopefully.
Something interesting, something dangerous maybe. It's a dangerous piece of kit by the looks of it. So I'm going to stand on here. Right. I'll insulate myself from the ground, so I'll get charged up with static.
And I'm ready to rush off.
Yeah, you might get zapped at that distance. Right, let's try it.
This Van de Graaff generator produces large amounts of static electricity.
Yeah,
it's coming up.
Just see very slight movements in the web.
Yeah.
Anything in contact with the metal sphere becomes charged, Tim included.
Very cool.
Incredible.
Really, it's cool now.
And you can see the webs pulling out to catch me. It really is incredible. So if I was a fly, I'd be tangled up in that web by now.
Yep. And the way it works, of course, is that an insect flying through the air, because of all the friction, basically charges the insect up.
It's a bit like when you're walking across a carpet and you charge yourself up and you touch a door handle and you get an electric shock.
All flying insects generate static electricity as their wings beat the air. This gives them a small electric charge. The sticky strands of spider silk are charged too, which makes them attracted to the insect.
So by the time the insect is close enough to say, oops, here's a web, the web licks out at it and captures it.
So when a fly, for example, approaches this web, well, it's not just the fly getting caught in the web, it's the web catching the flies.
Yes.
The web reaches out and grabs hold of it.
Reaching out and then sticking to it because it comes out and then it transfers the charge.
Now, in a real-life situation, this would be a fly that's flying through the air, getting charged up. So we've got a dead fly here, and we're going to charge it up through the machine via me and see how that affects the system. And there it goes. Jumps straight in. So this is a really surprising system. How on earth did you discover this?
It was partly deduction and partly luck, actually. Just let's do it. You know, like sometimes you have an idea, and then you go, and you actually try it out, and it really works.
So it was a surprise when it worked?
Oh, yeah, totally.
What an amazing system.
Yeah, it's pretty cool. Physics, together with biology, makes things happen. Yeah.
Spiderwebs are truly remarkable structures. And that's largely because they're made from one of the most extraordinary materials in the natural world, spider silk. But what is this gossamer-like substance and where does it come from? To find out, we need to look inside a spider's body. As an anatomist, I've dissected many things, but never anything quite this small. So we've brought in a specialist, Dr. David Knight.
So, David, I know much more about vertebrate anatomy than I know about actually any invertebrate anatomy. And I especially don't know much about spider anatomy because I tend to keep at a safe distance from them. So can we get inside this thing?
Yes. So we need to see if we can gently open up the skin.
First, David has to remove the tough skin that covers the abdomen.
Right, so if we open up here, see what we've got.
So what is this speckly stuff here?
That's branches of the gut, or it's connected to the gut.
This is a completely different anatomy.
It's a completely different way of doing it.
What we're looking for lies deeper inside.
Right. So if we open up here,
See what we have there. Carefully peel back the gut diverticularly. Yeah, we're getting close.
Right, there's a couple of silk glands.
Those are?
Yep.
These things here? Like two little pink sausages?
2 pink sausages of the silk glands.
So they're almost enveloped by all of these branches of the gut.
They are indeed. It makes quite a lot of silk, the house spider here.
These structures may not look remarkable, but they produce and store a true wonder material. But at this stage, silk is nothing like the tough fibres that make up a spider's web.
I presume when it secretes the silk to begin with, is it a fluid?
It's a fluid, yes.
So how does a fluid become a strand of silk, a
Yes.
fibre of silk, as it leaves the spider's body?
Well, it's stretched by the spider walking away or dropping from the ceiling. And that stretching pulls all the molecules into line and squeezes them together. They then lock solid into a solid thread. It's amazing.
Just amazing.
A spider has several types of silk gland within its abdomen, each producing a different kind of silk. These vary from strong and tough dragline silk used as a safety line to fluffy egg case silk used to protect its eggs. There's even a silk glue that anchors threads to their surroundings. This is a remarkably versatile material, highly elastic, tougher than Kevlar, and 5 times as strong as steel, which makes it potentially useful for humans too. Unravelling the secrets of spider silk is what drives biologist and materials scientist Chris Holland. He uses this strange contraption to harvest silk.
This is an incredible setup. What's going on?
In order to get some silk out of the spider, we have to very, very carefully pull it from its spinnerets.
Although it looks unnatural, this entire process is completely harmless for the spider.
You can see the really fine line of silk just coming from the end of the spider.
Absolutely beautiful. It's a very delicate material when handling it. But it just goes to show that for its size, it's incredibly strong. And what I'm just doing now is I'm just going to attach a little bit onto this motor to do the job of pulling it away for me.
And there it goes.
And there we go.
It's a real factory at the end of the spider there, isn't it?
It's the world's most remarkable polymer extrusion factory, definitely.
With this setup, it's possible to obtain about 30 metres of silk an hour. It's not practical on a commercial scale, but if scientists like Chris can fully understand how spiders spin silk, then perhaps they'll be able to produce artificial silk that's as good as the real thing, something that's proved elusive for decades.
It's amazing the potential that it's got into the future, looking at all the different things that you could do with this nature's wonder material.
Absolutely. Potential uses of spider silk can range from medicine. Some people have tried to grow nerves along spider silk, but they've also tried to produce it for different types of more structural applications. One day we may actually be running around with different types of sort of artificial parts of our body inspired by spider silk and how it's formed.
There's plenty to admire in the humble spider. So why are so many of us afraid of them? To find out, I've invited psychologist John May over to watch a movie.
In a small Wisconsin town, something was about to happen that would send shockwaves around the world.
I'm supposed to be spending the night in the spider house later in the week, and I certainly don't want to end up like this.
So these sorts of horror films really are playing on a fear of spiders, but how prevalent is arachnophobia? How prevalent is this fear of these eight-legged creatures?
Well, it's very common in Western culture. Around 25% of people are afraid of spiders to the point that, you know, they will avoid them, they'll ask somebody else to deal with them.
I mean, I'm aware that I'm nervous around spiders, and I try to cover that up in front of my children because I don't want to imbue them with that irrational fear. So I do try to be more interested than scared of spiders, but I'm sure my 4-year-old daughter can pick up on the fact that I do have that kind of frisson of fear.
I think it is learnt. It's something that it's very easy to acquire, which suggests there is something about a spider that makes it easy to dislike. And I think it's down to the fact that they have long, or tend to have long angular legs, and we know that people tend to prefer curvy shapes in general to angular shapes. And also, we don't like dark colours compared to bright colours, and spiders are generally camouflaged with dark colours. So they tick all the boxes for being disliked.
And that's why I'm really nervous about sleeping overnight in this house.
You're going to sleep here with the spiders.
We'll see. We'll see.
Good luck.
According to John, my fear of spiders is a learned behaviour. So the question is, can it be unlearned? Every year, London Zoo runs a special programme that claims to do just that.
And on a scale of 1 to 10, where 1 is mild and 10 is extreme, where would you put your fear of spiders?
Probably 8, I'd have to say.
This afternoon is a particularly important one for Dan. Later this year, he's going on the trip of a lifetime to Montserrat as videographer for a zoological expedition. But the thought of staying in a tent full of spiders is giving him sleepless nights.
For me, spiders are wrong on a lot of different levels. If someone were to ask me to draw the embodiment of evil, and I'd never seen a spider before, I still genuinely think I would draw like a big black dot with 8 legs.
Arachnophobia has a devastating impact on some of these people's lives. So what is it about spiders that triggers these fears?
Everything about their shape and the way they look freaks me out, really.
They just look menacing. They look cross with you. I don't know. It's the running, it's the way they move.
It's because they always surprise you out of nowhere. That's what gets me in a panic every time.
I'm John Clifford, I'm the hypnotherapist on the course. People really do not understand how a phobia works, how powerful it can be.
The course has a remarkable 80% success rate, using a mixture of cognitive therapy, hypnotherapy, and finally, exposure therapy.
Don't make it move.
Okay, I'm not going to make it move. I'm still holding on, I'm not going to let go. Okay.
Ah! Tony, touch it!
There you go.
That's amazing. I'm going to do it again.
There you go.
Go on, spider. Run away from me. Oh my God. That was so awesome.
Nice one. This is the bit that I've not been looking forward to, really. There you go.
Well done, man.
Yeah.
Did you want to try having him run across your fingers?
I don't see why not.
Yeah.
Yeah? Okay. This is the sort of house spider I would see.
It's exactly the sort of one that you'd see in your house. Really well done, man.
I felt that, just inside.
Yeah.
You're lucky I didn't fling it at you. Could have caused a stampede.
And if you thought that the British house spiders were maybe a bit small to see what was going on.
As a final challenge, the participants are invited to have their picture taken with a Mexican tarantula named Agatha.
Amazing.
Many here began the day terrified of even sharing a room with the spider.
Okay. Okay, that's all right. You okay?
So this is a huge achievement.
So do you think you'd be able to do this?
No, it's amazing.
Finally, it's Dan's turn to hold Agatha.
Okay. So I'm just going to bring you across into the palm of your hand. There she is. You've got Agatha. How's that?
Yeah.
Isn't she cool?
She's amazing.
The success of this course shows that we don't have to be afraid of spiders if we don't want to be. Almost everyone here today is now able to cope with spiders, including Dan.
I feel if I see one now with the understanding that I've got, I'm not going to be as freaked out as I was before, which is good because that was a major stress for me.
So far in the spider house, we've been looking at spiders who sit and wait for their prey to come to them. But today, we're going to meet a true hunter. The zebra jumping spider normally lives on a sunny back wall, but will come in a window if he sees potential prey inside. Don't be fooled by his small size. This natural-born killer has keen eyesight and the ability to jump up to 25 times his own body length to catch his prey.
Hello, Graham.
Hi, Alice.
We're trying to capture this incredible behaviour on camera.
That's one of the English zebras.
It's tiny.
Yeah, it is tiny.
I'm pretty sure I recognise
Yeah,
this
most
fellow.
people are a common visitor in the summer.
I think with some spiders, you're not sure that they're aware of you, but he seems incredibly aware of his surroundings.
You'll
Visually.
See. Oh, yeah. And when you see them in the wild, they'll see you approach and tuck out of sight and just watch you, watch what you're doing. It's a real visual hunter, and it's got two special forward-facing eyes for that.
And how far can it see?
Oh, good distance. It will certainly recognise if somebody walked through the door.
Really?
Oh, yeah, that good.
Gosh, yeah.
Jumping spiders are renowned for stalking their prey like a cat. But it's hard to see what's going on with such a tiny spider. So we've drafted in a larger one.
OK, you've seen the little one that lives in England? Yeah. This is a big relative.
He's a bit bigger.
Oh, it's a very, very similar North American cousin.
He's lovely. Oh, has he got green fangs?
Yeah, superb colours. So we'll tease it with a green bottle or a blue bottle? Green bottle. And we'll just see what he'll do. Now, he noticed it, see the way he sat back, he was actually pressuring his legs up. I'll just pop a few more in so we've got some more choices of food for him.
Oh. He's
not sure.
Is he? What's he going to do?
He's actually working out what it is.
Is he?
Yeah, because he's just gone in there, so it's a bit alien.
Yeah.
They assess whether it's threat or food.
He really kind of bunched up, didn't he, as the time passed. I could appreciate that he was very alert. And he's
actually just seen you.
Oh, has he?
Yeah.
He's looking right at me.
He's looking right at you.
Wow, I can see his two little beady black eyes. Now, I'm not your dinner.
Lovely, working out what it is, working out size. See how fast that is?
Oh, my goodness.
Isn't that superb?
Oh, gosh, that was quick. And it was interesting because he was poised and ready, and then suddenly sprang into action.
The jumping spider has made this catch look easy, but to finish the job, he must now kill the fly. He does this by injecting venom, a lethal cocktail that can kill in seconds. Most spiders kill their prey with venom. To look at how this deadly substance works, we need to extract some without getting bitten. This is a highly specialised job, best left to the experts. Steve Trim works with some of the most dangerous spiders on the planet in order to supply venom for medical research.
What I'm preparing here is our electrodes. The electrodes will touch either side of the chelicera on the spider, which is where the venom glands are held.
To obtain a sample, Steve must first gently sedate the spider.
The fangs are nicely relaxed.
Next, he stimulates the venom glands with a tiny electric current similar to the charge from a household battery.
So I'm delivering a first tiny pulse. And there we see a small droplet of venom.
The venom from this tarantula is powerful enough to kill a large mammal. But how does it do this? To find out, Tim is carrying out an experiment in the Spider House lab.
We've had a donation of a drop of blood on a microscope slide from Graham, our spider expert, and we've mixed it with a drop of tarantula venom. There's a whole range of different spider venoms all across the different families of spiders. Some of them are a mixture, a cocktail of potent neurotoxins that affect the nervous system, but this one is a cytotoxin, so this is something that affects the cells, and particularly the blood cells. So if something was to be attacked by this spider, well, the venom would instantly start to work on the blood cells, the oxygen carriers of the body.
Just seconds after the tarantula venom is mixed with the blood, the cells begin to change.
So you can see here we've got perfectly normal red blood cells with this really characteristic round, smooth donut shape. And then if I just pan across towards the venom, we start to see these strange looking globules. You can see just in the space of about a minute or two, well, the venom has really attacked these blood cells and degraded them completely. They've gone from this very smooth donut shaped to just kind of round, fuzzy balls. So there's no way that these blood cells could fulfill their function of carrying oxygen around the body. Spiders eat prey often many times larger than themselves, so spiders risk being injured as soon as they attack. But also they have prey that can escape very quickly, so it's massively important for a spider to really knock out the prey as soon as possible.
Spider venom is both powerful and fast-acting. But thankfully, it isn't something we should be worried about here in the UK. British spiders aren't particularly venomous, and most of our native species can't even penetrate human skin. Even the much-feared false widow has a bite that should feel no worse than a bee sting. Up to now, we've been looking at spider species that naturally find their way into our homes. But there is one exotic favourite that some people choose to bring home as a pet. The tarantula.
Hello, Graham. Well, thank you for assembling some tarantulas for me. I am learning to love spiders, but I'm still a bit nervous about ones of this size, I must admit.
Yeah, they're quite a big beast, but quite gentle. Think of it as an 8-legged hamster.
With fangs?
Yeah, with fangs.
Tarantulas are really widespread throughout the world, so why don't we get them in Britain?
Really, our weather doesn't suit them. Our winters kind of pulse a little, so we have long, damp spells where they couldn't be active. They would be sitting in burrows where mice will get them, mould or fungus would get them. And you can see that some of these really show off the colours in sunlight.
Oh, she is actually quite pretty. I have to admit it.
Yeah, she's a very pretty spider.
So she's got orange hairs on her opisthocyma, her abdomen.
Yeah.
She's got stripy knees, and she's got silver hairs on her front legs.
They may have their charms, but I wouldn't want such a big, hairy, venomous creature in my house. But there are thousands in Britain who do. Tim went to the British Tarantula Show to find out just what it is that makes tarantulas such popular pets.
So what have you got in your box? What have you bought?
I've got a few spiderlings, and then this is sort of what my main purchase was today.
Yeah, and what is this one?
It's a Heteroscodra macrolata. I just think it's one of the most beautiful species you could get.
Have you just bought this one?
Yeah.
How many have you got?
Got ruby, scarlet, rosy, bandit, velvet, and pizza.
Why is it called pizza?
Well, it's the common name for the species is chili red flame, and my mum thought that sounded like a pizza.
You look a bit nervous to me.
Very nervous.
Why is that?
Terrified of spiders.
So you're scared of spiders, but you've ended up at a spider convention. This must be the worst place.
I know, to try and help us.
And has it done the job?
No.
But the serious arachnophiles are really here for one thing and one thing only: the tarantula competition.
Really nice fringing on the femurs, lovely black velvety dark legs. It's a first-class specimen.
Sometimes nicknamed the Crufts of the spider world.
Peter, you're judging the spider competition now. It's not like with dogs where there's a kind of gold standard golden retriever, is it? When you look at the spider, what's the first thing?
First thing we do is a leg count. We've got to make sure they've got 8 legs.
Because sometimes they've got legs missing.
Absolutely, they've got legs missing, but the good thing about spiders is they'll grow them back. What we're really looking for is something that displays the known colours of that particular species as vividly as possible. And one of the most important things is that the abdomen is in proportion to the size of the spider. We don't want to see a spider that's too overfed.
Well, I think we'd better let you get back to your judging. You've got your work cut out, haven't you?
OK, thank you very much.
Cheers.
I'm lucky enough to meet some of the top competitors.
Now, these special spiders.
Yes, it's a special spiders. It's rare spiders, but it's a small spider, so I don't know if I will be the winner or not, because they are small, but they are very beautiful.
And have you won a prize yet?
I have a prize regularly.
Really?
Normally, yes. I hope this year too.
These ones come from trees. They live in trees. This one's a highland species, so it's one that you don't often see. I'm not very good at pronouncing this one. It's Cerealpagarus sheldati.
That's easy for you to say.
It's not, actually.
Next, Brachypelma species. Jean-Michel Vedette. Okay, best in show. Bono Centrobus Balfouri. Mike Dawkins. Best New World Arboreal, Peter Lacey.
It's a different Peter Lacey.
So, Mike, congratulations. You won the
Thank
best
you.
in show. How does it feel?
Brilliant. Didn't expect all of that.
Yeah. What will you do to celebrate? Have you got a plan?
Pub.
To go to a pub? Are you going to take the spider with you?
Nah, just in case.
Does she have a name?
Her name's Lola.
Lola,
Yeah.
fantastic. Well, it's lovely to meet you. And
Thank you.
It's lovely to meet a champion of the 8-legged variety.
I've put it off as long as I can, but the moment I've been dreading has finally arrived. Tonight, I'm going to spend the night in the spider house. By morning, I'll know whether I've truly conquered my fears. What worries me most is whether I'll have spiders running over me in the middle of the night. I'm hoping Graham can put my mind at rest.
Now, Graham, there is one thing I really wanted to ask you, which is about this idea that spiders crawl across our faces and that we eat a certain number of spiders in our sleep every year. Is there anything to it?
We hear it a lot, but the way spiders react, as soon as they touch someone, they're aware of you. Just breathing on them, they run away. And touching your skin, they know that you're a person or a big animal. So, no, they're not going to walk across your face.
So it's a myth?
Yeah.
Well, that gives me some reassurance about sleeping here in the spider house tonight.
I'm glad of that.
Once Graham and the crew head home for the night, I'll be alone with the spiders. All I have with me is an infrared camera. My room. I might just have a quick check for spiders. It's relatively spider-free. There's a rather lovely moth just there. Can't see any spiders over there. Right then, time for bed. Okay, I'm just about to go to bed, but I've discovered an unwelcome guest in the room. See, that spider is not going to be spending the night with me in the room. I know Graham said they don't climb into your mouth. I don't want you running over me at all. I might just leave it there. Sorry, spider. Okay, well, I've just spotted somebody else who's definitely not going to be spending the night with me tonight. Is that not the biggest spider? He's not staying in here overnight. Yeah. 2 friends from my bedroom. I'm sorry, guys, you're spending the night in there. I'm really tired now. I don't think I can put it off anymore. I'm going to have to try and go to sleep. It's about 1 o'clock in the morning. And the crew will be arriving back in the house at some ungodly hour. So I better just put thoughts of spiders out of my mind and go to sleep, I suppose. So, good night. Good night, spiders, wherever you are. Good night, BBC 4. Well, that is early morning sunshine filtering in through the window, so I have slept in the spider house, and I had a really good night's sleep. I didn't feel any spiders running over my face in the night. While I've been sleeping, my housemates have been hard at work. Graham, hello.
Hi, good morning.
Good morning.
This frame was empty when I went to bed.
She's made an absolutely beautiful web.
Oh, yeah, look at that.
Can you see her? Oh, she's tucked in up here.
Yeah, up under the roof.
Yeah. So while I was asleep, she built that rather wonderful web.
You mean you didn't watch?
I didn't see her doing it, no. That's really wonderful.
I must be feeling more at home with spiders after such a good night's sleep. But what I'm going to see next is the stuff of nightmares. We're about to experience the dark side of the spider. Conflict, cannibalism, and cold-blooded killing. Spiders aren't exactly a sociable lot. One step onto another's web, and it's a fight to the death. Most will kill and eat members of their own species, as well as any other spider they come across. It really is a spider-eat-spider world. The best place to see this is down in the cellar, where we're studying a spider that at first glance looks like he wouldn't hurt a fly.
Now, this is probably one room in the house where I did expect there to be spiders.
Yeah, and in fact, it's full of cellar spiders, quite predictably.
So what are cellar spiders?
Well, the cellar spider is another name for the daddy long-legged spider, and it's a perfect habitat for them down here.
These are the ones that live in my cupboard under the stairs.
That's right.
And I'm quite happy for them to stay there and just get on with it. Yeah.
Yeah, well, they're a really impressive species, actually, and they've made a huge tangle of web around it. What's interesting about these is that they live communally, and it's one of the only spiders that we find in the UK that will actually tolerate each other.
The daddy long-legged spider is one of the most recognisable spiders you'll find in your home. They originated in the tropics and prefer a warmer climate. So here in the UK, they're almost exclusively found in houses and outbuildings that protect them from our cold winters. Those distinctive slender legs are the daddy long-legged spider's secret weapon. It uses them to ensnare its prey with silk, whilst keeping its body at a safe distance. Only once its quarry is safely cocooned does it go in for the killer bite. Those long, wobbly legs can perform a defensive trick too.
There's another really interesting thing about these spiders is they've got an interesting defence mechanism. If we go in with our specialised prodding stick and just give it a tap in the web, and they're gyrating round and round in circles.
So he's doing that deliberately? It's not just that he's sort of lost his balance and he's trying to regain balance again?
That's right, yeah, it's really characteristic of this species, and it's a behaviour known as whirling. Usually it lasts about 30 seconds, but then in some situations they've been known to do it for as long as 2 hours, constant gyrating round and round in circles.
So why are they doing that? I mean, how can that be useful as a defence mechanism?
Yeah, well, what we think is that these are attacked by visual predators. So predators like jumping spiders, which have really, really good vision and might crawl up to the web and actually pinpoint the spider and attack it directly. So by spinning round and round like this, they disappear in a bit of a blur of spider body and legs. So it makes them very difficult to pinpoint.
But it's a mistake to think that a daddy long-legged spider will do anything to avoid a fight, as some spiders discover to their peril. This large house spider has wandered down into the daddy long-legged spider's domain. It looks like more than a match for the spindly daddy longlegs. But this is the ninja of the spider world. Those long legs have spun a silken trap around the house spider's rear leg. Once the web is strengthened, the house spider will be done for. But before the daddy long-legged spider can finish the job, the house spider breaks away, and this time lives to fight another day. It's a lucky escape. The cellar is littered with the corpses of other, less fortunate house spiders.
One of the special tricks of this spider is to move into the webs of other spiders, like house spiders, and actually eat them in their own webs.
Oh, really?
Yeah, so they're really voracious predators. They look very, very delicate, but they're actually really good at catching other spiders as well.
The spiders in your house live in a brutal world where it's kill or be killed. This poses serious problems when spiders want to mate. How does the male spider convince the female he's not just another meal? And where else would we study this than in the bedroom? We filled this room with female spiders. Once they're established, we'll introduce the males. We're hoping to record the dangerous business of spider courtship and reveal the truly bizarre world of spider sex. Our guide is Professor Karim Vahed, an expert in spider sexual selection and sexual conflict.
Karim, we've got some spiders here that should be ready to mate. So this is a false widow spider. The male and the female, they just physically just look really, really different to each other.
You often find that in spiders. For females, there's advantages of being big. The bigger they are, usually the more eggs they lay. For the male, there may actually be selective advantages of being small. For one thing, males run a very real risk of being eaten during sex in spiders, either before or immediately after mating. And it may be that if you're smaller, you're less noticeable and perhaps less likely to get eaten.
It's a dangerous world with this guy. Let's keep our fingers crossed for him, I suppose. Good luck.
He seems to have located us straight away. Now, ooh.
So that's aggression, is it, from the female?
She's looking pretty aggressive at the moment. I don't think he showed enough courtship. I think he went straight in there without being gentlemanly enough to give her a bit of courting first.
He was very gung-ho.
Absolutely. Now, he's going to have to do a better job of courtship than that, because she's not impressed at the moment. Now, it may be, you see, that she's already mated, and she may be more interested in him as a meal rather than as a suitor. I mean, when you're a member of such a predatory species, that's a danger that a male spider faces.
So maybe we should save him from the jaws of the female.
For spiders, courtship isn't just polite, it's a matter of life and death. So males have evolved a variety of tactics to convince potential partners of their honourable intentions.
In many spiders, the male has all sorts of vibratory signals he sends the female, and other courtship signals, like rocking his body. The male is basically saying to the female, I'm the right species, I'm a male, and I'm not food, don't eat me.
Our cameras captured some of these strange rituals with a courting orb-weaving spider and house spider. The male often begins by delicately plucking the female's web with its feet. Or sometimes bobbing its abdomen. If the female doesn't attack, the male moves closer. But even making all the right moves doesn't guarantee success. In some species, courtship is even more elaborate. For spiders with good eyesight, it's all about getting the female's attention. In Australia, there's a species with one of the most bizarre attention-seeking rituals in the natural world. The peacock jumping spider. But sometimes even this extravagant display isn't enough. Back in the bedroom, Kareem suggests trying a more friendly female.
So we have a stand-in female. Now, this one hasn't been mated, so she should be really receptive as opposed to that last one that was quite aggressive.
Well, hopefully. And it's possible that the male may even be able to smell that difference. The silk has all sorts of pheromonal cues in it that the males can actually sense through sense organs on their feet. And the males apparently can actually sense if a female is a virgin or not.
Great, let's drop her in.
Be good if you took some of the web with her, because that'll have her smell on it. Right, let her get settled for a few seconds.
So this is the web of our non-mated female, so if we incorporate that, then maybe the whole web will smell of an unmated female.
Let's see what the male does.
Right, let's give him a chance for mating. Take two.
Ah. Now he's on the move.
So he's sensed where he is. He's sensed that there's a female nearby. Here he goes.
He's gently tapping her. You do quite often find gentle tapping of the female occurs when they get close.
And compared to that last female, she just went straight for him, but this one, she's just sitting there very calmly.
It's a little bob of the abdomen.
This time, the courtship seems to be going well. But when it comes to actually mating, things start to get very weird indeed.
Now, they do things in a very, very different way to the way that we mate, for example.
Yeah, really, we have to completely rethink our concept of sex when it comes to spiders. For one thing, the male doesn't really have a penis as we understand it. Bizarrely, they actually use their front pair of appendages, like a little pair of front legs, if you like, called the pedipalps. Now, in males, these are much larger, and they have these syringe-like enlarged ends. And what the male does is he uses these to transfer the sperm to the female. But first of all, he has to charge them up with sperm. So what he actually does is he has to deposit his sperm on a little sperm web, and then he uses the syringe-like pedipalps to suck up the sperm. The male will then go underneath the female and insert either one or both of his pedipalps into the female's reproductive openings, which are just underneath her abdomen.
We had to be patient. But eventually, we managed to capture this remarkable behaviour on camera. The female false widow can store the male sperm and use it to fertilise her eggs for up to 2 years. But the male will now leave her web, and it's unlikely he will ever meet his offspring. The weird world of spider sex is all about one thing: making more spiders. In the final room of the house, the nursery, I'm going to meet the next generation. Their journey begins with the female spider weaving a cocoon of protective silk. Inside this, she lays her eggs. In the case of this false widow spider, up to 100 of them. The silk protects them from predators and helps to control temperature and humidity. All spiders start their lives inside these silk cocoons, but not all egg cases look alike. The false widows look like little bundles of cotton wool. The house spiders are similar, but often decorated in items the mother has eaten. While the daddy long-legged spiders carry their egg cases with them in their jaws. We've been watching the egg cases in the nursery closely, and one's just about ready. So I'm going to be on hand to help some of our spiderlings take their first tentative steps into the world.
Hey, Graham. Oh, I'm so excited about this. I've never seen spiders actually hatching out before.
It's a great thing to see. In fact, better than that. Why don't you do it?
Oh, I'd love to. I'd be a spider midwife.
Yeah.
So they're definitely ready to come out?
They're ready to come out, and you're just going to tease them open a little, that egg case. It's all ready to hatch. Nice and gentle. That's it.
There was somebody just there, just coming out.
Yeah.
Ooh. It's quite tough, actually. It's tougher than I expected it to be.
It's got to protect them.
Come on, little spiders. Time to wake up and come out into the world. Oh, there's one just walking out, look.
That's it, they'll all start wandering.
Just teasing the edge of the egg case there. And I'm doing it really carefully because I don't want to hurt anyone inside. Again, tearing it open. So there they are. Oh, that's amazing.
Yeah. Starting the journey. They'll feed in a day or so.
And what do they eat to begin with? Because presumably they're too small to catch anything at this point.
Yeah, they're not going to catch big prey, so it's all got to be micro prey. But they'll also take food that's airborne, so even dust particles, bits of pollen coming in, that kind of thing.
So they'll start spinning immediately?
Oh, yeah, they'll make little miniature sheet webs. They're perfect little adults, miniature adults.
It's an incredible thing to see these little baby spiders emerging into the world. I feel quite maternal towards them, Graham.
So you should.
A few days later, some of the other egg cases in the nursery also begin to hatch. And our cameras were on hand to capture this amazing sight. The false widow's egg case is nearly translucent, the spiderlings clearly visible within. They'll stay close to the mother's web for several days before dispersing. The female daddy longlegs keeps her offspring even closer. She continues to carry her egg case in her jaws even after the spiderlings emerge. As these tiny spiders grow into adults, they must go through an extraordinary physical process that begins while they're still inside the egg case.
very gently pop it down.
Dr. Sarah Goodacre is going to show Tim this remarkable transformation in the largest spiderlings of all, the tarantulas.
Wow, look at that. It's so busy in there, look, so full. Look at that, it's just amazing.
It's a really privileged view, isn't it? Not many people get to see this.
No, absolutely not. It's amazing to see the different development stages that they've gone through.
And all of these very, very delicate light shed skins, they're the kind of evidence, I suppose, of these various stages as it becomes less like an egg and more like one of the giant spiders that we've seen.
Unlike humans and other vertebrates, spiders don't have a skeleton inside their bodies. They have what's called an exoskeleton. The outside of their body is covered in a tough, rigid shell. To grow bigger, spiders first need to molt their outer skin. Most spiderlings will do this several times before leaving the egg case.
So we can see here that a small spiderling is actually in the process of molting.
So this is the really delicate stage. This is actually molting as we speak. It's shedding its skin, gently pulling its legs out of its exoskeleton. A bit like a foot being pulled out of a really tight boot.
Spiderlings can molt up to 12 times before they are fully grown adults. It's an exhausting and dangerous process. Spiders sometimes finish a molt with fewer legs than when they started. Having shed its old exoskeleton, the spider increases the pressure inside its body, inflating and stretching its soft new skin. This quickly hardens off to form a new exoskeleton, bigger than the one before.
It is just amazing they have to go through this whole molting process, every individual, every single time, to get bigger, and that's the only way they can grow.
I suppose inside, before each molt, there's a kind of bigger spider just waiting to get out, ready to squeeze itself out of that skin and expand and become a bigger individual.
And you can see just how complicated it all is to get everything happening in the right order with all those legs. But you can imagine how vulnerable the spider is at this point.
It looks so soft and delicate.
Life is hard for a little spiderling. Very few will survive to adulthood. Yet despite their small size, they can travel a surprisingly long way by performing an acrobatic stunt called ballooning.
So Sarah, we've got a new generation of spiders in this pot, and they've got a really special trick, haven't they?
Well, they have. Well, really, the main reason why I've studied spiders, and I've done that for more than 10 years now, is because spiders have a particular ability that is, I think, completely amazing. And that is that they can use silk as a sail and fly.
And lots of them are all streaming down.
Streaming out. Here's a couple here. Actually, I've got one here on the top of this stick that keeps tipping its abdomen into the air, and that's known as tiptoeing. So they go up on tiptoe to kind of get that little uplift and then shoot out a line of silk.
You can see exactly the behaviour that you were talking about. It's sticking the end of its abdomen in the air, so that's sending out a stream of silk,
yes,
waiting to take off.
And from that position, they really are judging it, and now seems to be not too windy, but just the right level of gentle gusting and updrafts. And if they decide they want to balloon, they have to actively let the silk out, and then they have to let go and let the silk carry them up and away. Here goes one, there he goes.
Oh, yeah. Well, there's one just going off right into the air. They really are going for it. This one is still attached to the pot that's in my hand, but it's starting to, just as the breeze picks up, it's starting to kind of swing out into the breeze.
Actually, you've got one just ballooning past your nose there.
I thought I could feel something, yeah.
One of them was about to go into my armpit, which, you know, may not be exactly where I want to have a spider.
And
And I suppose where they actually land is kind of down to the luck of the draw and where the wind takes them.
Absolutely. These are the risk takers. These are the risk-taking species that get everywhere.
And how high can they actually fly?
So they're going up to the height of the jet stream, so it's hundreds of meters up potentially. By next week, it could be somewhere else in continental Europe. And by the week after, could be much further afield than that even. And in fact, when new islands pop out of the ocean, when volcanoes erupt, often one of the first things that arrives are the spiders. Spiderlings, from all the species of spider you'd find in the spider house, have this ability to balloon. And yes, they may very well choose to fly and end up in someone else's back garden, in a farmer's field, or indeed in someone's home. And that's actually a really good thing. We should welcome them in because they do nothing but good, eating the pests we don't want. And also they're endlessly fascinating creatures to watch and learn about and understand.
It's not just the spiderlings who are leaving the house. Our time here is also coming to an end. And that means saying goodbye to all our spiders. We brought them here from nearby sheds, outhouses and woodland, so now we're returning them to their former homes. By seeing how they lived in the spider house, I've discovered a hidden drama that's going on in all our homes. And while I'll never love spiders as much as Tim, I now have a whole new appreciation of these much maligned creatures. They may sometimes give us a fright, but they also kill flies and other pests in bathrooms, bedrooms and kitchens all around the country, making our homes cleaner and healthier places to live.
I think that many of us, when we go inside our houses and shut the door, like to think that we're shutting out nature. But we can't do that, and actually, neither should we want to. Now, none of us wants to be overrun with spiders, but accepting that there are always going to be a few of them living in our homes is about accepting that we are part of the natural world and that it's in our houses as well as outside. So I think we should be happy that to some extent, every house is a spider house.